Welcome to today's example, the second one from Chapter 7. This one's from 7.2, confidence intervals for the mean. I went ahead and repeated the same steps, and again, hopefully you already printed them out, so you don't need to be looking at them here. I will point out today, since we're talking about doing means, we get different formulas for step 4 and step 5. For step 4, the margin of error is the critical value, but this time it's TC, because we're using the student's t distribution, times S over the square root of n. For step 5, constructing the confidence interval, the formula is very similar to the last formula. This time it's x bar minus e less than mu less than x bar plus e. So we're still adding and subtracting e from the point estimate to estimate the parameter. So keep that in mind when it comes time to get there. You're going to find I like to do a lot of cereal examples because you'll be surprised to know I don't eat cereal, but I figure we all know a lot about cereal and we can understand the importance of it. So notice this question says calculate a 90% confidence. So again, it's a Chapter 7 question. And it is asking us to circle a confidence interval as our final answer. So we are going to go through those 6 steps. So what parameter are we trying to estimate? We're doing a confidence interval for the mean. So we're trying to estimate mu, which means we need those formulas that I just listed on the previous slide. So when you look at those formulas, and I'll go back to them for this example, E is not a statistic, it's the margin of error. TC is the critical value, but S we know is a statistic for standard deviation. N is a statistic, it comes from the sample. And X bar is a statistic. So we need to know X bar, S, and N. And as I mentioned in the last example, I always like to do N first. Here N is a little bit in hiding because they didn't spell out the numbers, but they did spell out the word. It says 20 boxes are sampled. So N is 20. X bar, S, take your pick, whichever one you want to find next, reveals a standard deviation of 4.9. So 4.9 for S, and a mean of 377.8. You can include units on these or you cannot include units. It's not going to be a big deal. The only place I really care about units is in your confidence interval and your interpretation. Everything else in between, in fact, I'd be more worried about having units when you shouldn't. So step 3, which I think was the critical value. Yep. So since we're using the student's t distribution, it is still a bell-shaped distribution, and it is still centered at 0, but the standard deviation is not 1 anymore. In fact, the standard deviation depends upon the degrees of freedom, which I'll write up here, the degrees of freedom, sometimes called DOF or sometimes just DF. In this class, the degrees of freedom are always n-1. Other examples, other classes, that's not true, but in our class, it's always n-1. It's still a confidence interval, so it's still two-tailed. This time we want to be 90% confident, so we put 0.9 in the middle, and then each tail would have to be 0.05 to add up to 1. It is the t distribution, so we call it TC, not ZC like we did the other day. And our Excel command is hopefully fairly reasonable. Remember, we did norm.m the other day. Now we have t.m. There is another Excel command that you can use. I find students tend to make more mistakes when they use that command. So I am not going to teach it in any of my videos. But just to let you know, there is another one. What I like about t.m is it's just like norm.m in that when it asks for probability, it's probability to the left. And I didn't put it on my picture, but we're still going to make a mark on the right one because, again, we need a positive number. So at that mark, the probability to the left is 0.95. The difference is, unlike norm.m, it's going to ask you for degrees of freedom. So we already said that N was 20, so my degrees of freedom, N minus 1, is 19. So let's calculate this critical value. We have T dot M of 0.95, comma, and notice it says deg freedom. It's asking for degrees of freedom, which is 19. So we get 1.73. Step 4, the margin of error. So we have 1.73 times S, we said, was 4.9, divided by the square root of 20. And as we mentioned in the other example, make sure you don't type in 1.73. Make sure you cell reference the 1.73 because it's not exactly 1.73. So we click on it, times, we had 4.9 divided by the square root of 20. We get 1.89. One thing we didn't have to worry about with proportions, but I would point out here, if they do ask you for the margin of error somewhere, there are units. It is 1.89 because both X bar and S were in grams. This is 1.89 grams. Please note that 1.73, any critical value has no units. No critical value has units in this class. And then to find the confidence interval, so X bar we said was 377.8 minus we had 1.89. So 377.8 was X bar minus, and there's my E. And then 377.8. Oops, I forgot the equal sign. Plus E. So 375.91 and 379.69, if I can remember those. Which I can't. 379.69. Now I will show you two different ways that you can write your answer. One would be like that. One would be like that. Either way, you're showing me you know what the confidence interval is and you know what the units are. I think the interpretation is just a smidge bit easier than it was with proportions, but it is very similar. Again, we start off with the same phrase. So we are 90% confident that the, and last time I used the word proportion, today I'm going to use the word mean. And then last time we talked about the mean, we talked about what were you counting. But today, tell me what were you, usually the best word to use is what were you measuring? In this case, we were measuring the amount of cereal or the mass of the cereal or the weight of the cereal. Be careful that what goes here is not a unit of measurement. Don't say the mean grams. But tell me what specifically you were measuring. So the mean mass, oops. And then the of all part. And again, just like with step 5, you can put the grams at the end, or you can put a notation beside each number. So very similar to yesterday's lesson. Hopefully you see the similarities. And again, if you have any questions, please contact your instructor.